Okay, today we've been working on this review for Chapter 10 in Algebra 1B on the quadratic functions. And we really only have a few problems left. So I'm going to kind of skip ahead to where we left off in Part 1 to finish up Part 2. So here, use any method to solve this. If necessary, round to the nearest hundredth. So here is our equation. So probably the easiest way is to use that square root property that we were using before. So add 6. So 8x squared equals 6. Divide by 8. So x squared equals 6 over 8. And I wouldn't even care about reducing it at this point, because really I can just do plus or minus the square root of that. So in my calculator, just make sure when you do square root that you do parentheses 6 divided by 8. So in other words, when this goes in your calculator, it should look like this. So if I hit enter, I end up with x equals plus or minus 0.87. So let's go back and look. So here we go, right here. Okay, next one. Now these are pretty easy because we're going to actually use the discriminant. Because the discriminant is what tells how many solutions you have by using this. So I'm actually going to split this twice here. And actually, I think I might actually take this and move it down just a little bit. So we can identify our A, B, and C. So on this first one, A is 1. There's no B value, and C is negative 18. So let's see, 0 squared minus 4AC. So if I was to plug that in my calculator, I end up getting a positive 72. Which means any positive answer means that you have 2 solutions. So on this one, my answer would be C. Now let's go to this next one. Let me get another color here. On this one, A is 1, B is 5, and C is 7. So if I plug these in, so 5 squared minus 4 times 1 times 7, I end up getting negative 3. So any negative number means no solution. So that means my answer would be B. Okay, which of the following functions has the narrowest graph? So really that's based on the A value. To find the narrowest has to have the largest A value. The widest has the smallest A value. So if I'm talking about A, let me just turn my highlighter on for a minute. I'm talking about this value in front of the x squared. So if I look at these two, if I want the narrowest, I choose the largest number. So my answer is going to be B. Okay, just a couple more left. Graph the set of points. Which model is the most appropriate for the set? So we only have 2 here. So let's see if we can find which one goes in the right spot. So negative 6, negative 1. So negative 6, negative 1, there's not even a point, so it can't be A. So I'm hoping to God it's B. Negative 6, negative 1, that point checks out. Negative 3, 2, that checks out. Negative 1, 4, that checks out. And 2, 7, that checks out. So those 4 points are all right. And also if I was going to look at this, I can see they all line up, which means it has to be linear. So remember, you're checking it, and you're also checking that piece down there. Okay, now on this one, This one says the table shows the estimated population of the deer living in a forest over a 5-year period. Are the data best represented by linear, exponential, or quadratic model? Write an equation to model the data. Now the good thing for us is it's either going to be exponential or linear. So we have two choices. We can go through and graph this, which would certainly work. But also remember, if it's linear, then the change has to be the same all the way down. So let's just see on this one if it happens to be the same. So 91 minus 70 would give you 21, so it went down by 21 here. To go from 70 to 54, it went down by 16. 54 to 42, it went down by 12. From 42 to 32, it went down by 10. So even if I were to look at this, I could tell the changes aren't the same, which means that it can't be linear, which means it has to be exponential. Now, on some of these values, one of the things that we can do is we can actually go through and plug a couple numbers in and see if this works. So for example, if I were to try this one right here, I plug in an x equals 1, and I should get out a y equals 70. So if I do this, and I should be able to plug this part in my calculator, and I get 70 back out of it, which means that it checks out.